I'm going to hit the go live button and not screw up this time. Yes. Why? YouTube, why do you. Why? No, it's not YouTube. It's not YouTube's fault. It is a little bit YouTube's fault. I'm just too used to Twitch. I used to stream a lot on Twitch, and it's just like, oh, I'm going to hit the go streaming button, and therefore it is immediately on the interwebs. It's like, no, that is bad. That's not what YouTube does. But hello, my name is Max. I'm going to switch back to this one. Welcome to day 3 of the Advent of Code. I am Max. I'm a professional software developer, even on the weekends. And this is a weekend, and so today we are going to be doing day 3 in Rust again. We'll see how it goes. Hopefully it'll be under an hour. Although yesterday was a relatively straightforward problem, and it took us over an hour, or about an hour to do. Yes, this series is not a critical success by any stretch of the imagination, but that doesn't matter because we're having fun and we're learning about programming at the same time. So without much further ado, let's get cracking. So rucksack reorganization, exciting. An elf has the important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, they didn't follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. Right, okay. The example is going to help us here because I'm not immediately grokking that problem. The elves have made a list of all the items they need your help find. Okay, each item type is identified by a single lowercase or uppercase letter. That is, A and A lowercase and A uppercase refer to different types of items. The list of items for each rucksack is given as characters, all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, and the second half of the characters represent items in the second compartment. Okay, so suppose you have the following list of contents from 6 rucksacks. The first rucksack contains the items VJ, blah, 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 which means its first compartment contains half of that, and the second compartment takes the second half. The only item type that appears in both compartments is a lowercase p. Okay, so it's item types that are being shared between 2 strings. Okay, that should be relatively straightforward. To help prioritize item rearrangement, each item type can be converted to a priority. A lowercase item types A through Z have priorities 1 through 26, and uppercase item types A through Z have priorities 27 through 52. In the above example, the priority of the item type that appears in both compartments is 16, so that's lowercase p, L, V, blah, 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 blah. Some of these is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of priorities of those item types? Okay, awesome. We have our puzzle input. So let us make a day 3. We might even just duplicate. We don't even need to duplicate. It's fine. So day3.rs. We'll copy some code. There we go. I'll probably just our read lines for the moment. Okay, so first things first. We want a way of looking at our example and making sure that we get out the values that we are expecting. So I'm just going to quickly paste these in. And so what we need to do is essentially we need to split this into equal strings and then split each of those strings into individual characters and then put each of those individual characters into sets, and then we need to find the intersection of the sets. So I'm hoping that Rust has some stuff to. I mean, I definitely know Python does. I could do this in Python. Whether I can do this in Rust in a nice, coherent, straightforward example is going to be a different thing. So we're going to start off with strings. So let's start with a test. Example step 1, and we're going to do our standard results. box din stud. Now there are ways of like abstracting that away, and we could probably do. So I know anyhow is a good one actually. There is the option of importing a new crate to be able to handle some of these errors. And you know what? Let's do that. Let's start the day by adding a new crate to our thing. So we're going to start with anyhow. Anyhow is the is similar to it's similar to this error. It's by the same author. Whereas this error is sort of defining error types. Anyhow is sort of giving you an option of being able to throw away those error types because nobody cares, or you don't actually care about what the error type actually is. So what that means is that any type, anything that is an error, can be converted into an anyhow error, and so I can just put question marks everywhere throughout my test code, and it'll just handle it, which is good. So we also need a function which so we want to split into equal length strings, and our input is going to be, what's our input going to be? Like, we could just do a string reference, I guess. The question is, what do we want to get out of it? And I think the answer might be we actually want some string slices out of it. So let's see about so input string is going to be a reference to a string, and we're going to output two strings. Possibly we should think about what happens in the I mean, it could be that we actually want to give this make this an option. And in the case that it is an empty string, we just return a none. So we could do that. Let's do that. Okay, so what we're saying is if input dot is empty, we're just going to immediately drop out. We're going to go return none. There you go. And otherwise, that's an interesting one actually, because now there are a couple of error cases with this. So the question is, do we actually want to be using the AOC error here? It's entirely possible we want to just be returning an error of AOC error generic, and we say string was empty. But we also want to be raising an error if the why are you complaining? Oh yeah, there's no else. That's fine. I don't care about there being an else. I'm just going to do that for the moment. It's going to complain because these types are not the same, but that's fine. So we also want to complain if the string length is not equal to a modulo of 2. So if input.len modulo 2 is not 0. So what modulo 2 means is, so this percent sign means modulo. Modulo 2 just means, so for all even numbers, it's 0, and for all odd numbers, it's a 1. Not equal to 0 here is just a semantic way of trying to imply that we actually do want a 0. Because what we're going to be doing here is just returning an error, AOC generic odd string. There we go. So now we have a string that is definitely of the right length, or at least it is of different lengths. No, it isn't of an even length. So now we can split it into two substrings. Given that we have the input length, I mean, we might just want to. So let's go to our code, Rust string slice. I think there might be like a slice at position. Possibly slice at. slice at, or split at, possibly split at. Here we go. Just go through. There's the split. I think there might be a split at. Come on, come on. Because this is all splitting at indices. I want it to actually split at a position. There we go, split at. Divide one string slice into two at an index. The argument mid should be a byte offset. It must also be at the boundary of a UTF-8 code point. Panics if mid is not at UTF-8 code point boundary. Well, we should be fine. I think we should be fine. I'm sure it's fine. So what we're going to do here is have let's just do let x for the moment equals input split at input.len over 2. Good. So that's actually going to give us our string slices out automatically. So if I just do that, we should, yes. And this is now going to this should be complaining, I think. If we try and look at the Clippy error here, yeah, this wants to actually passes in a string slice because all the options we're doing here can work on a string slice just the same as it could work on an actual string. So that's good. So we have our function. So if I just do let x equals split into equal length strings, and I pass in this and question mark, and then we do println, and then we're going to debug show x, and that is going to show us, hopefully. Yep, now it's split into two parts. Excellent. That is exactly what we wanted. So now we have two tuples, or we have a tuple with two string slices. We want to get sets out of both of them. Now the question is, does Rust have a set? And I do not know that off the top of my head. Here we go. We have a hash set in stud collections hash set. That's pretty cool. Awesome. Interesting. So the question now becomes, we're going to import that. So use the stud collections hash set, and we're just gonna have a create set function. Create set from slice. There you go. So we're going to have inputs as a string slice, as we had before. I'm just going to ignore the return type for the moment. So we're going to have input dot iter. Should be able to iterate over a string, I think. Chars, yeah, chars. So we want the characters. It is already an iterator at this point, I think. So if I do let this equals this, no, I would let x equals this. Show me what x is. X is chars. Chars, gonna tell me what a chars is? Go to char. Go to char. I think chars is an iterator. Yeah, because all of these are iterator methods. That's fine. So I think I should be able to collect these, right? Good. Let x set, and we're going to say hash set of, now the question is, what do we actually get out of chars? What type is, I think that is literally a char. I don't know if, oh, can I do this? I'd be excited if I could. Compiler. Does that work? The compiler seems to be happy. So maybe this works. Hash set char. So I might even be able to get away doing just that. There we go. Awesome. So let's parts equals split into the thing, and then we're going to let sets equals we might as well we could just make it a tuple as well. Yeah, create set from slice parts 0 parts 1. That does feel a little bit weird to do this, but yeah, maybe we'll handle the logistics in a second. The niceties. Okay, so you're complaining about this. Oh, parts dot 0. Yeah, good. So again, the compiler is helping us out by saying, actually, you want to be using parts dot 0 and parts dot 1. And if I now say sets, this should print us out lovely 2 sets. And now we want to do a set intersection, which we can do with dot intersection. And that gives us the values that are both in self and other. So we might as well just do let intersection. Let intersection. Hopefully that hasn't imported. Yeah, it has imported something. That's just an errant entering there. So dot intersection. Now I'm not saying we should definitely do this in coding, but having it all on one line is actually quite nice, I would say. You want a reference? Does that work? Is that good? Is that good for you? Now this is the question. Like, is it actually going to show us? Ooh, creates a temporary which is freed. Yeah, I thought it might. Interesting. So what I might want to do I actually want to just immediately do this into I might want to put a little helper function here, split into sets as an input. There we go. And we're just going to wrap all of our functionality here. We're going to say let part 1 part 2. I think I should be able to unpack like this, so that should be good. Put a question mark in, and then we want to be returning another tuple. So I want to be so actually get intersections. So let part 1 set equals create set from slice part 1. Part 2 set is create that from part 2, and then let intersection equals part 1 set dot intersection part 2 set. So now we should have an intersection. Oh, that one's a reference. That's fine. So that should give us an intersection of the sets. So all the characters that were in both sets, which is exactly what we wanted. So if I just print that out, intersection, our result is going to be. What is that result going to be? It's going to be an AOC error, isn't it? For the moment, it's going to be a blank string. And an AOC error. Why are you complaining? Oh yeah, because I haven't actually returned OK. There we go. That's a good point. So I'm going to say let intersection equals get intersections for our input. Our input is this. And for the moment it does nothing. So if we run the test, we should have it printed out to screen by our other thing, and we can see our intersection is P. There is 1. That is fantastic. So we need a way of scoring that intersection, and the scoring mechanism is lowercase A through Z have priorities 1 through 26, and uppercase A through Z have priorities 27 through 52. So we want a scoring function for our intersection. Now we could be like, there's a couple of ways we could go about this. But I think I might just loop over it. I might just use an iterator. I'm assuming there's an iterator on a char set that I can use here to give out a value. Again, we're going to use unsigned 32s. So intersection dot, can I into iter? Yeah, great. Good. So it's going to turn it into an iterator. It's going to iterate through all the characters, essentially. I've used, Magic on Tap says, I use a lot of languages, never Rust, and I have no idea what is happening. Good. I will try and explain as I go along, but I mean, a lot of the syntax here is just syntax. The programming concepts behind this are, I think, relevant across a bunch of different languages. So, for example, if I was doing this in Python, there is a set built into Python directly, so you could just do set of the characters you want of a list of things, and then do I think it is set.intersection in Python as well. So you just do another intersection. I mean, all we're trying to learn here is the methods for actually getting from the solution. We're trying to build up the building blocks to see at what part we're doing things. But I'm doing it in Rust because I like writing in Rust. It's a really good language, a really fun language. And it is, there are some, like I said on day one, there are some rough edges on it, but it's really nice to get into. The Rust book is very, very good. It is sort of like the tutorial, and going through that introduces a lot of concepts. There are still very hard bits of the language, but they are getting better as time goes on. So we have an iterator. An iterator basically is just going to loop over every element in this set. So I want to map it. I want to map that character. So we have a character C here. There we go. So we have a reference to a character. So we want to get the value of that. And we think it's going to be either an A to Z lowercase or an A to Z uppercase. And we want to map those into 1 to 26 or 27 to 52, right? That was the there we go. I have this thing in my, there we go. We have it in our things. I should probably have a look at it. I got turned down for a job at Mozilla because I'd never used it. It seems like it's becoming more common. It is, I would be surprised if it's not one of the larger languages come the next couple of years. I really would be surprised because it's just got into the Linux kernel. That's a big deal. That's a really big deal. So yeah, getting into the Linux kernel, and one of the nice things about it is that I like about it is that it's you don't have to worry so much about the boring stuff like memory management. It handles all your memory management for you. Lifetimes of objects. Once an object is done with, it will throw it away and get rid of it for you. The only bugs you get, in theory, are logic bugs, and there are still logic bugs. But if you're reducing your debugging domain to logic bugs, that throws away a whole raft of things. And things like multi-threading are just, they're so, like, once you get into multi-threaded programming, it's just like, oh, okay, I now need to think about what the ownership of items across my entire code base. It makes it a lot easier to do that. And if you get it to compile, you're pretty confident you know it's going to work in the long term, and you can end up with some really convoluted programming. I'm a JavaScript developer. Memory management is a 4-letter word to me. Yep. We'll just new everything. It's fine. I used to use. I've done a little bit of JavaScript in my time. I used to be a web developer, in fact. So yes, that was an exciting time of my life. I want to have a look at. I want to see what chars do. Let's have a look and see what chars do. So if I look for char, utilities for the character type. So here we go. Can we turn it into? See the char primitive type. Here we go. It's a Unicode scale value. Can it turn into a number? That's what I want to do. I want to turn it into a number, please. Is it decode UTF-8 16? I don't want. Oh. Okay. Is ASCII digit. I think one of the things I'm going to do here is like I need to be 2-digit. Converts a char to a digit in the given radix. Gosh. So the problem with this is that we are talking about Unicode characters here and not ASCII characters. If it was ASCII characters, like a lot of other things do, they've got like code points and stuff, and we know that it's just ASCII, right? So one of the things we might be able to do here is just like get away with going, yeah, it's fine. What do I want here? I mean, I could just literally Google for it. I should be able to do this. I don't. You can tell obviously how often I actually use lower level characters. This is not something you tend to do in Rust programming. In most programming in general is like individually going through characters. So yeah, I feel like it feels like 2-digit probably makes the most sense, but honestly that doesn't fill me with confidence. Decoding UTF-8 16 does kind of make sense, but then what does len UTF-8? This returns the number of bytes this child would need if it encoded in UTF-8. This number of bytes is always between 1 and 4 inclusive. Okay. We could do pattern matching, like we did yesterday. We could do some pattern matching. I commend you for looking at the docs because I can't read. I will try. Oh yeah, I zoomed in the other day. That's right. Damn it. I was zooming in the other day so people could actually read it on the stream. Yeah, here we go. Hopefully that's a little bit better, and I will remember to do that in future. But yeah, the Rust docs are probably one of the best bits of the Rust language for working in, because a lot of these are like auto-generated, but they also have examples, and the examples are tested. I can hit run here, and this will go along and put this code into an online version of Rust, and it will run the code for me in the background. And you can play with Rust code in your browser. It's really good. It's really, really, really good. I think I'm going to need to Google this. Rust convert char into ASCII value. Parsing a character to U32. Here we go. If I have a code like A is 29, print this. 2-digit for the radix. That's an expect. Hacky solution. See as U32. So I could just cast it to a U32. Yeah, that's fine. All right. It does look like we can. Oh, that's interesting. There are some blanket implementations. I'm just going to say try from U32. Is there a try into U32? That's the next thing. So a lot of these, a lot of the code in Rust has got things where you can try and convert from one thing to another. I tell you what, let's go and have a look at U32s. U32s are unsigned 32-bit values, and I would be surprised if there's not an implementation of. I was hoping to scroll down from all the way from the bottom. There we go. There we go. There is a from char. Converts a char into a U32. Excellent. Okay. So that I think gives us a number out. So it took us a long time to get there, but we should be able to get a number out of this. So U32 from char. Char is called C. So it's taken us a while to get to this point, but let's do let x equals that. It knows it's an iterator over item 32, but this is not the end of the end of the task. So lowercase items A through Z have priorities 1 through 26. Lowercase. So the problem with this is that our characters, with this value, we need to actually map it to something sensible. So in ASCII, let me see if I can actually print these out. I wonder if I can print these out, because that would be really cool. If I can print this out and show you, and I'm just going to quickly do 0. There we go. Return a 0. Println U32 value for blah is blah. So we're going to say C, and our U32 value is going to be X. There we go. Nice. We always like having single things. You're complaining. Oh, because you... Okay. You're complaining because this is a reference and we haven't actually owned the intersection, and the implementation is not on a... Fine. I wouldn't... If I do that, are you going to complain? All right. It is going to complain, but it's fine. When in doubt, you can clone things, and this is... yeah, this is fine. Fine for the moment. I'm going to let Clippy handle it for me. So our intersection. Let's go back to this part. So we have our intersection here, part 1 intersection. We're going to do that, and this is going to give us... well, it should actually give us the complaint. It should say, hey, you were expecting to do one thing, and inline intersection. All right. No, don't do that. No. Why are we complaining? The complaint here is because I think it returns a type of intersection ATS, and we need to actually define that. So let's see if we can do that. So it's an intersection hash set. There we go. The life... interesting. Now we're starting to get into lifetimes. That's exciting. Haha. So let's see if we can do some lifetimes in Rust and really boggle some people's noggins. What is the T? T is the type of the iterator. The hash set is a T, so we're gonna have char. Char? And then S is... Oh, I can't remember what type S is. Oh, this is going to be a pain, isn't it? Can I just do that? I don't care what type it is. Just return whatever type. Return with... Okay, there we go. Return with the correct return type. Static char. Stud collections random. Yeah. So actually, I can just get this. I can get the compiler to fix this up for me by doing that. Because I don't want to think about it. I just want it to work. There we go. In fact, I'm going to do lifetime of A, and I'm going to do that. This is... I'm going to see if this complains at me. Oh, how do I do this? I think... Is that lifetime? That's lifetime. Why are you complaining? Cannot return a return value returning local variable part 1 set because I'm borrowing things. Okay, not the time to introduce lifetimes. So lifetimes in Rust are one of the weirder bits of it. The concept of a lifetime is that you how to define it. So everything in Rust has a lifetime. This input has a lifetime. Like, and because this is a reference, we care about when we create this thing and when we get rid of it. Because if we're operating on something, and in the background it goes away, that will be bad. So all the coding I've done at this point, up to this point, has sort of had like implicit lifetimes involved with it. And all of these references has got sort of like implicit lifetimes involved with them as well. So if I actually wanted to be like, if I wanted to be explicit, I can say this, for example. There you go. So I can say there is a lifetime named A on this function, and the lifetime tied to this, and I think I might even be able to like include that. I can't remember what the syntax is off the top of my head, but I can include the lifetime of that for my hash set. Although I think actually this lifetime is not, because this is actually creating a new object. It creates an entirely new lifetime. Not a good example, but if I had an example where I'm taking in one reference and then splitting it into two parts, say, yeah, so for a split string, for example, yeah, these values, if I just define this here, we can easily say that there's a lifetime of A related to the input string. So our input string lasts for however long it lasts. This function should, I think, have it spits out two string slices that are of the same lifetime. So I think in theory this is a completely valid syntax, and the compiler is not going to shout at me. So what you're saying is, given the input string, your output strings also last for as long as your input string lasts for, which makes sense, because like if you have a string that's sitting in memory somewhere, you split it into, you get the string view out of that, and then you split that string view into further bits of string view. They still refer back to the original object. So if you get rid of the original object, those string values aren't valid anymore. Now, if you wanted to make them valid, you could clone them and turn them into like newly allocated strings, but we don't want to do that. But one of the nice things that Rust does is it's called elision, which is a nice word, and it elides lifetimes on common functions, and it makes them look normal. So lifetimes is one of those things that you could probably quite easily go through a lot of coding without knowing anything about, but then you start getting into interesting problems like, what does an intersection give out? And then you start getting into some fun. So one of the things I do want to just quickly look at is, given an intersection, can I just turn that back into a I just want to turn that into a set. Can I just turn that into a set, please? I know it's the same thing, sort of a scope on a timescale. Exactly. Yeah. It's a very good way of saying it. So I kind of want to know if I can. Oh, it's a lazy iterator producing elements. Oh, okay, so it's an iterator, right? If it's an iterator, I can turn it back into a hash set. Let's do that. So yes, yeah. So we actually want our function to give us something useful, right? that is the outcome that we would like. So I'm going to say hash set of chars out. That is the outcome that we want to have. This is an iterator, and one of the nice things again about Rust is I should just be able to call collect and have this work. It might start complaining because I've got the types wrong, but let's see. Let's go cargo test, and I just want to get the actual spitting out value. Okay, type of hash set char cannot be built from standard iterated items. Okay, so the problem is here that we have references, and what we actually want is to map those. And I think there's a way of doing that, but I'm going to let the compiler tell me about it. c.clone.collect. So what I'm doing here is actually cloning the characters to get out a copy of the character, and then collecting that. And then this is going to tell me there is a fix that I can do. Consider calling the dedicated copied method. There we go. I will do that. So we have part 1 intersection copied. So that turns it creates an iterator which copies all the elements, and then we collect it. So now we have an owned set of characters. There we go. So that is what we want. We want to end up with a hash set full of characters that essentially we own. Like possibly we could do something. I mean, there's a lot of allocations here with like hash sets and allocated stuff. And I'm going to try and delete that and fail miserably because I do not have Studio. 1 second. Just time to block some nonsense. There we go. And hide user on this channel. Bye bye. Never mind. Spammers. First time I've ever been spammed on YouTube. Exciting. It's good. So I now have an intersection. I've got a hash set with my intersections in. I've got a score hash set function. So let's score equals score intersections. Ampersand intersection. Thank you. That is exactly what I wanted to do. I might even be able to print this. Should have printed something out there. Did I not want to have a good time or whatever it said? I blocked it immediately. Yes, yeah. I unfortunately tried to do it from this window and it didn't do it. So never mind. I was hoping it was going to print me something out there. That's mildly annoying. Should be able to. Well, let's just double check. This is why we have debugging. We want to make sure at each point that we don't screw up. So intersection, at least for our example, like while we're coding the example, we want to make sure we get the right thing. So there's a P. So I'm pretty sure this should print something out. The compiler might be going, "Hey, what are you doing? That's a stupid thing." So yeah. Tell you what, let's just do .sum and yeah. Let's not give the compiler a hard time. Let's just do some standard code. There we go. So I should get a printout line which tells me, yeah, there we go. A U32 value for P is 112. Our score is 112. Excellent. So let us go to ASCIItable.com. ASCIItable.com is very, very 80s, 90s, whatever looking. There we go. But we can see on here that a lowercase p is indeed code. Ooh, what it says? Okay, so decimal 112. Yes, that is exactly what we had. So this is in decimal. Good. So what we're saying is if it's between a and lowercase a and if it's between lowercase a and z, we have priorities 1 through 26. Uppercase items a through z have priorities 27 through 52. So we need a way of mapping essentially from values. So our lowercase value is 97 to 122. So if I write 97 to 122, and our uppercase values, I know it's 65 because once you've done enough coding, you know that capital A starts at 65. Uppercase is 90. Okay, good. So we need a way of essentially converting that. And what we could just do is we could just do some very, very noddy like range conversions. Probably the easiest thing to do. I just want to quickly double check Rust match integer range. So I think I should be able to match on a range. There we go, 2 to 9. So that is kind of interesting. I don't know if I can then spit out the value after that. So that's... Oh, there's some match guards. Match arms can accept match guards to further refine the criteria for matching a case. Exciting. So, interesting. And then the other thing I wanted to check was pattern syntax as well. So I can print like ranges here. ... equals an inclusive range of values. Now the question is, can I match as? Oh, I could have just matched using these. I didn't even need to use the. I didn't even need to use the thing. Okay, well now that I know that I can do this, I'm going to go back and get rid of the entirety of the U32 stuff that we did. So you know, that was useful. That was a useful time. Never mind. The question is, can I get the letter out afterwards? I'm hoping I can, so we'll see. So match. Actually, no, because we do want the U32 value because we want to be subtracting from it, right? So we still do want that. So let char C value equals U32 from C clone. Then we're going to match C value. So we want to match from 97 ... equals 122, and we're going to map that to C underscore value. So we want to take off 96, and then we want we're going to match values 95 ... equals 90, and that's going to map to value C value minus 38. Mathematics. And then we're going to say anything else is 0. So I think that should spit out the right value for us. I hope. That's not the right syntax. Underscore is the right syntax. Now you're going to complain. Right, let's do some call directly iter, and then you're going to say try dereference. Oh, I could just dereference it. Okay, fine. That's what that's telling me, as I can just use *C. Good. Okay. So this is now going to tell me the score. The score is 16. Now the question is that does that jibe with the thing here? And it does. 16 is P. So the next one we want to test is this, and it's going to be capital L, and that should be 38, right? So let's go back to our code, and I should do let score equals score intersection. Now the question is, do I actually care about the intersection once I've dealt with it? So I could just delete this. And so I have to pass ownership of the intersection to it, because I don't actually care about the well, at the moment I don't care about the intersection. And what the nice thing about that is I should just be able to paste this bit into this bit and get a essentially one-liner. And the reason I find that interesting is that I can now duplicate that and do that for my next thing. Not that. Not that one. There we go. Let's copy the right string. There we go. This should give out a 38. So we should get 2 scores. We should get 16 and a 38. And we do. Excellent. Good. So now we want to essentially do this. It's time to do our first step. We're 50 minutes in and we're just finishing our first step. So step 1 is going to be from... we'll just get our result out. So we're going to use our helper function, let lines equals advent of code, read lines, input slash day3.text. Okay, and so we want to iterate over each of the lines, and we want to essentially map that to getting the scores out of that. So question mark. So we have a vector of strings. Excellent. I'm just going to OK at the bottom because we don't actually care about the result. So lines dot iter. So we want the sum, don't we? We wanted the sum of all of these. So lines dot iter, and we're going to map line. So we're going to end up with, yeah, we have a string. So I want to pass that to score intersections, get intersections. Now, first things first, I want to map that, send that to get intersections. We're gonna do some nice coding. There we go. So let intersections equals this. So this is actually gonna that gives us an iterator. Collect gets us to collect, and what we're going to do here is actually say that this is a result. So one of the nice things about this is, because this is a fallible function, get intersections is a fallible function, it returns a result object, and we don't want a vector of result objects. One of the nice things about Rust is that you can essentially, with the collect function, turn a vector of results into a result containing a vector, and that'll essentially just error at the first error, if that makes sense. So instead of the outcome is that without much thought, I can have a vector of what are we actually calling these? These are hash set chars. A result vector hash set char, and the error is going to be an AOC error. I think that should be good enough. I might be missing some lines. How's that? Got to get the right number of lines. Char. There we go. Good. So this is now a result of hash set of chars, and we're going to question mark on that. So we bubble up the error to the function. We know for definite we now have a vector of hash set of chars, and now we're going to iterate on that and map that. So we got hash set, and we want to pass that hash set to a non-fallible function, which is score intersections of hash set. We want to dereference that, and we should be able to do that. Or you're going to tell me I can't do that? Why? Do I want to be iter mut? Does that give us ownership? It does give us ownership. Good. You're going to complain because... okay, I didn't want to... Okay, right. So this is the point at which, oh, actually, we don't care about having an AND hash set. All right, I'm just going to turn that back into an AND hash set, and hopefully this is not going to shout at me too badly. Good, it doesn't. Excellent. A lot of Rust is unfortunately playing with some lines like this. So yeah, we're all good. So there we go. Score intersections, and we are going to. So that's an iterator, and we've currently got an iterator on U32s, and then we're going to sum them. So that is going to be a score. We're going to call that a U32, and this is going to shout at me because I can just map to the score intersections, because essentially this is called a closure. This is a function that has one input and then calls a function, and because we already can do that, score intersections is just a function which takes an input and gives out an output, then we can just do that. It's essentially removing one level of indirection there. So we're essentially saying this unsigned 32 type is the sum of a bunch of unsigned 32s, and again we probably might get, well, we could get an overflow. It's unlikely. So that should be our day one. Step one sum is this, and we print out the score and we run it, and we get our number out, and we get a whole bunch of errors at the top. Like, why are you using this thing? I am using the read lines function. I don't know why that's complaining about it. It's probably because it's behind a test. Yeah, it's because it's behind a test thing. Our sum is 8,153. So hopefully, typing the numbers 8153 in here, give us the right answer, and they do. Fantastic. Okay, so as we finish identifying the misplaced item, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Each elf carries a badge that identifies their group, and for efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is of item type B, then all 3 elves will have item type B somewhere in their rucksack, and at most 2 of the elves will be carrying any other item type. The problem is that somebody forgot to put this year's updated authenticity sticker on the badge. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Nobody wrote down which item type corresponds to the group's badges. The only way to tell that is the right one is finding the one item type that is common between all 3 elves in a group. Each set of 3 lines in your list corresponds to a single group of elves, but each group can have a different badge type. Okay, so the first example, the first group's rucksacks are the first 3 lines, and the next group's and the next 3 lines. Thanks for that. OneDrive. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. This must be their badge. In the second group, their badge item type must be Z. Priorities for these items must still be found to organize the sticker attachment. Here they are: 18 R for the first group and 52 Z for the second group. Some of these are 70. Find the item type that corresponds to the badges for each 3 elf group, and what is the sum of the priorities of these item types? Awesome. Okay, so how can we do this? Interesting. So we want a way of splitting our line iterator into so Rust iterator. I want a way of chunking that. In fact, if I just type chunks, because that's what I want to do. Excellent, chunks. Created by the chunks method. So what I want to do is have chunks of 3. That's all I want. I want three chunks of items. So we're going to get out see chunks exact for a variant of this iterator. It always returns chunks of the same size. There we go. So chunks exact. If I get chunks exact 3, that's always going to give me the right number of elves. And then we just have to pass those into our scoring functions and we should be good. Right? So, step 2, let lines equals the same thing. So, first things first, we want to get our let groups equals lines.iter.chunk. Oh no, yeah, iter. It should be iter. Why have we not got chunks? Oh, maybe we don't have them on chunking an iterator. Maybe that's... Oh, because that's on a slice. Interesting. Okay. Iter-tools might be a good crate then. Chunks for more information. Iter-tools is so Iter-tools is a decent crate. Chunks makes chunks of this size. It turns it into chunks. Return an iterable that can chunk the iterator. Yields sub-iterators that each yield a fixed number of elements. Okay, it is iterable and only buffers. What does an interchunks do then? I do not know how to get the values back out of that. Oh, does it give out an iterator? Okay, it might itself give out an iterator. That will be fine. Cool. All right. So we might actually have to add the iterator tools crate then, which will be good. Yeah, let's do that. So cargo add iter tools. Again, really nice and straightforward. Just going to immediately give us access to the tools we need. Use iter tools. I'm hoping it's going to give me chunks. Yeah. Now the question is, I don't know whether that just immediately gives me. I don't know whether that just gives me chunks on anything that implements iterator. I think it might. Okay. So let's see. Actually, let's get rid of that because it's not a function I can call. So here we go. So that's into iter dot. Can I just chunks? There we go. Nice. Returns an iterable that can chunk the iterator. Good. So if I do map at this point, and we'll see what type X is in here. Size. Yes, we should probably give it size. 3. Thank you. The method map exists for struct itertool, but its trait bounds. So what is this actually outputting then? What is this actually doing? It gives us an into chunks. Maybe this isn't what we want to do. Maybe this isn't what we want to do. Let's go back to Rust iterators. So I think there's some there should be some base ones. Yeah, there's take while. There we go. There's take scan. I kind of just want to take a number of elements at a time, right? I just want to take the next 3 elements at any given point. How hard can that be? Nth. Turns the nth. No, I don't want the nth of anything. Array chunks. I mean, I do want that. That does look like the one I want, but it is an experimental API, and probably we don't want to be dealing with experimental APIs. I thought this would be easier. Rust chunk. I suppose it's actually not a built-in thing in Python either. So, okay, so it does use the. Everyone's pointing back to the itertools one, and it gives out an iterable. Okay. All right, let's try that then. So into iter dot map. What is type C, please? It is a chunk. What is a chunk? Tell me what a chunk is. How do I access a chunk? Like, what do I do with a chunk? Come on. That's VS Code being silly. An iterator for elements in a single chunk. Iterator element type is I item. Okay, so we have an iterator here. So, okay. So this is now the chunks themselves. Good. So how do we want to handle this? So there is a thing called folding, and reducing as well. There you go. Iterator reduce. Let's see if we can come down to reduce. Yeah. So reduce the elements to a single one by repeatedly applying a reducing operation. If the iterator is empty, return none. Otherwise, return the result of the reduction. So the reducing function is a closure with two arguments, an accumulator and an element. For an iterator with at least one element, it's the same as fold. Oh, it's okay. It's the same as fold. But no. Same as fold with the first element of the iterator as the initial accumulator value, folding every subsequent element into it. Okay, so I do want this. This is reduce. So I want to do C dot intuiter dot reduce. So each of these elements is no, I realize I have screwed up slightly, because the first thing I want to do is I want to turn these into hash sets, don't I? That's what I really want to do. I want to turn each of these strings into hash sets of themselves. So how did I do that? Oh, it's creating set from slice. There we go. So let hash set lines equals lines.iter.map line. And we're going to create set from slice line dot collect, and so we're going to end up with a vector. Well, are we? That's the next question. So we could go straight into chunking. Chunks of size 3. So now we have an iterator over our hash sets, which is what we want. And then we want to go into an iterator, and then we want to map. This is where it starts getting a little bit mind bending. Chunk. But because it's Rust, and because I'm fearless about doing Rust, we should be able to do this. So we're going to do chunk.reduce, and then we have a thing, and this is going to be element. And this element, I'm hoping this element is going to be why are you complaining? Why are you complaining? It's not telling me why it's complaining. Yeah, so reduce, it gives us the option of a self item. So I'm hoping this is actually going to give us out because it should be chunking over. It should be chunking over these. Create set from slice. Right. So the elements in the chunks should be, I'm hoping, hash set chars. In fact, I'm going to tell it about it right now. It should elide it, but hopefully it's going to do that. So now we're going to say, oh no, because this should take. No, I've just realised I've done a dumb thing. Oh, this is a hard problem. Why is this such a hard problem? Oh, chunks. Why did it have to be chunks? I don't want to go and do so. I don't want to just do a loop. Looping is horrible. Like, there is a nice way to do this. There is a nice way to do this that turns these things into sensible. Let's close that. It turns this into a sensible way of doing things. I'm wondering if, like, can I just take iter.next? Okay. I'm just wondering if I can take the values directly out of the chunk. Like, I should be able to go. Yeah, I'm going to do this. Okay. So let elf1 equals chunk dot. Can I just do dot next? And that's going to give me out what? An option. Okay, that's perfect. I'm just going to unwrap it for the now. I know, unwrapping is bad. Unwrapping can panic. We're at the point now where I don't care. It's probably fine. All right. So now we end up with 3 hash set chars. And I'm going to end. I want to do. So I want to do elf1 dot intersection with elf2. Can I do not intersection again? I'm really hoping I can. I can't. That's devastating. Okay. Let elf1 and 2 equals this. Oh, because it's that's right, because it's an iterator. Okay. Collect hash set char again. Lovely. So now we're going to end up with elf1 and 2 dot intersection of elf3, and we're going to collect those as another hash set char. And close that. And I'm hoping beyond hope. Why are you complaining? Why are you complaining? You shouldn't be complaining. You're like, intersection is an iterator, right? Oh, is it? It might be complaining because actually, yeah, fine. So okay, so now we got out hash set chars. That's good. So we have all of the intersections coming out, and we want to score those intersections. And we already have a function to score intersections. So I'm going to do score. Where's my score? Score intersect. Yeah, dot map. Yeah, and then dot sum. I'm hoping. Unfortunately now this is where the whole let's make it compile comes into play. That's fine. Like a lot of the coding here is just trying to make the compiler happy. So I think that's right, and I want to know why you don't think that's right. So we're going to go cargo test, and it's going to shout at me a lot and tell me, but the compiler is very good. Compiler will say, a value of hash set char cannot be built from an iterator over elements of type char. Oh yeah, because I didn't do copied, did I? I bet I need to do dot copied, which is what I did. Fine. How about that? Can I do that? Yeah. Now you're happy. When in doubt, copy. Hash set map. Oh yeah, okay, fine. So we're going to end up with an intersection, and actually, we need to be scoring the reference to the intersection. There we go. Are you happy now? Now you cannot borrow chunk. Cannot borrow chunk as mutable as is not defined as mutable. Can I do that? All the red lines have gone away. That is a good start. We have a sum. Is it the right sum? We do not know. So let's explain what our code is doing at this point. So we start by saying lines, which is a type of vector string. We're going to iterate over those. We're going to create an iterator, which basically just is a way of saying, well, an iterator is just a trait that says you have a point and some state, and you have a next. You have a next method. We can call next on you. So we're going to iterate over the vector of strings. We get out a type of iter string. Because we know that type implements anything that implements iterator has a map, we can say map. And a mapping takes a closure. We say, so a closure is just a function, and this function maps from references to strings. So line is a reference to a string. We're going to create a set from that string slice. So now we have a hash set. So it's just a set of the characters within that slice. But that's an iterator of them. So we have for each line in the file, we now have a hash set instead of a string line. We're going to separate that iterator into chunks. So that chunk, we're going to have chunks of 3. So within, and then we're going to iterate over that object. That's just a way of saying that's just a way of iterating over it, because we want to actually consume that object. And then we're going to map on that iterator, and then that iterator is spitting out chunks. It's spitting out chunks of 3 every time. So on its next operator is spitting out a chunk of 3 things, and within that chunk itself is itself an iterator, and within that iterator it spits out itself 3 items and then stops. So what we have here is we go chunk next, chunk next, chunk next. We get out our 3 hash sets corresponding to our 3 elves. We are then intersecting all the elves together. So intersect elf 1 and elf 2, collect it into a hash set char. Then we're going to intersect elves 1 and 2 with elf 3 to work out all of the ones that are intersected together. So that should end up with a hash set of the intersected characters, which should just be the 1. We hope that's just the 1. And then we already have a function which can score our intersections. And so all that together, that spits out a number, and then we sum the numbers together. That should give us our right score. Our score is 2342. Let us go into Advent Code, type in 2342 and hope. Right answer. Thank goodness for that. Wow, that was a in Rust, that was a hard problem. There are probably easier ways of doing that in other languages. Oh, we got the spammers back again. Hello, spammers. Go away, spammers. Bye-bye. But yeah, that was a good time. Gosh, it's taken us 80 minutes to do that. I don't know if there could. I think there are probably some better solutions to some of these parts. He says, "I'm glad you're doing this and not me." Well, I'm glad you're watching. I'm glad you're having fun watching. I'm kind of presuming you're having fun watching. I'm having fun. I'm having fun trying to puzzle it out in my head. But yeah, that is Rust. And one of the nice things about this, as you saw, this is all really, really complicated code, but it's quite nice. In Ruby, it would be a line. It would be 1 line. If it was in Awk or Bash or something like that, I'm sure we could get it down to 3 characters if we really, really wanted to. But one of the nice things about Rust and Rust Analyzer in particular, which is the tools that I'm using here, is that it makes it really simple at each point to try and reason about what the code is doing. And a lot of the code you'll do in everyday life, if you are a professional developer, is trying to understand what the heck is going on. So the fact that the code base here is just like, oh yeah, fine, we want you to, we're working through all these things. You have sensibly named methods. You can work out what's going on. It makes it easy to refactor as well. But anyway, that is day 3. I will leave you now because I'm not sure anyone wants to watch watch an hour-long or indeed an 80-minute long video about how to do coding. But yeah, I hope you had a good time. I'll see you again tomorrow to try and get